In this video, we'll describe antiderivatives and use the notation plus c. This is the 4.9 pre-class video. Remember when we would describe a position as a function of time, we'll use y of t, and we would take the derivative of position to get velocity and take the derivative of velocity to get acceleration. Well, sometimes you actually start with acceleration. Say we have a value of negative 9.8 as our acceleration is constant, and you might recognize this value as the acceleration due to gravity for objects in free fall. So in this situation, we know the acceleration, and we want to figure out what is the velocity. Well, since we know acceleration is the derivative of velocity, we're wondering what function, if you took the derivative of that function, would give us negative 9.8. Well, that would be negative 9.8 multiplied by t, right? Because if you take the derivative of that, you get negative 9.8. But that's not all of it. We could add this arbitrary constant because the derivative of a constant is 0, and still if we take the derivative of velocity now, you'd still get acceleration. Let's go one step further and figure out what is the position. Well, since velocity is the derivative of position, we're wondering what function, such that when you take the derivative of that function, gives you velocity. Well, that'd be negative 4.9 t squared plus c1 times t. Check it out. If you use the sum rule and the power rule for derivatives, you'd get our velocity function. But again, that's not quite all of it. I can add this arbitrary constant, I'll call that c2, because the derivative of a constant is 0, and recognize now if you take the derivative of our position function, you'll still get back to our velocity function. Let's look at one more example. Say our acceleration is cosine of t, so therefore our object's acceleration is oscillating between the values of 1 and negative 1. And we're wondering what is the velocity? Well, what function, such that when you take the derivative of that function, you'd get cosine of t. Well, that'd be sine of t. And don't forget, adding an arbitrary constant, because if you take the derivative of an arbitrary constant, you get 0. So if you take the derivative of sine of t plus c1, you would get cosine of t. All right, so that's the antiderivative of cosine of t. Now, what's the antiderivative of sine of t plus c1? Well, it would be negative cosine of t plus c1 times time. But we can add an arbitrary constant because the derivative of a constant is 0. So if we take the derivative of negative cosine of t plus c1 times t plus c2, where c1 and c2 are arbitrary constants, we would get our velocity function. So again, the new thing here is that we're doing the reverse process of before. We're not taking derivatives, we're taking antiderivatives. Let me clarify this idea of having an arbitrary constant included in our antiderivative. Well, if our function f of x is equal to 8x, and we want to find the most general antiderivative of f of x, and we'll denote this most general antiderivative with capital F. Well, we're wondering what function, such that if you took the derivative of it, would give you 8x, right? We're not going to take the derivative of 8x, which would just be 8. We want to do the reverse process. What function, when you take the derivative of it, would give you 8x? Well, in this case, it would be 4x squared, right? Because power rule would give you back 8x. But we can also add some number. Say we add 3, because if we take the derivative of 4x squared plus 3, you still get 8x. But we could subtract 9 or add 72, right? Both of those, if you take the derivative, you still get 8x. We could add any arbitrary constant, and so we denote that with a plus c. Plus c is an arbitrary constant. Including this arbitrary constant gives us the most general antiderivative. If you replace that arbitrary constant with a particular number, that'll give you a particular antiderivative. So an arbitrary constant gives you the most general antiderivative. You could also think of this capital F function now, this most general antiderivative, as a family of parabolas, right? Where each particular parabola is shifted by some constant relative to other parabolas. And each one of those particular parabolas is a particular antiderivative of 8x, but the most general antiderivative is 4x squared plus capital C. Well, that's it for this video. Hopefully that has warmed you up for this next class.